Black holes are some of the most mysterious objects in the universe. They are invisible, yet they have a tremendous impact on the space around them. In this video, we will explore the fascinating world of black holes and learn about their properties, their formation, and their effects on the universe. Black holes are regions in space where the gravitational pull is so strong that nothing, not even light, can escape. They are formed when massive stars collapse under their own gravity, creating a singularity, a point of infinite density and zero volume. The gravitational force of a black hole is so strong that it warps the fabric of space and time, creating a region of space where the laws of physics as we know them break down. Black holes come in different sizes, from small ones that are only a few times more massive than the Sun, to supermassive ones that are billions of times more massive than the Sun. The smallest black holes are thought to be formed from the collapse of individual stars, while the largest ones are thought to be the result of the merger of multiple black holes. Despite their name, black holes are not actually black. They emit radiation, known as Hawking radiation, which is a result of quantum effects near the event horizon, the boundary around the black hole beyond which nothing can escape. However, this radiation is very weak and difficult to detect, so black holes remain mostly invisible. In the next segment, we will explore the formation of black holes and the different types of black holes that exist in the universe. Black holes are formed when massive stars run out of fuel and can no longer sustain the nuclear reactions that keep them shining. When this happens, the star's core collapses under its own gravity, creating a singularity, a point of infinite density, and zero volume. The outer layers of the star are blown away in a supernova explosion, leaving behind a compact object that can be a neutron star or a black hole, depending on its mass. The mass of the remnant determines whether it will become a black hole or neutron star. If the remnant is less than about 3 times the mass of the Sun, it will become a neutron star, a highly dense object made up of tightly packed neutrons. If the remnant is more massive than this, it will continue to collapse under its own gravity until it becomes a black hole. There are also intermediate mass black holes, which are thought to be formed from the merger of smaller black holes or from the collapse of massive clouds of gas and dust. These black holes have masses between 100 and 100,000 times that of the Sun and are still relatively poorly understood. Supermassive black holes, on the other hand, are thought to be formed from the merger of multiple intermediate mass black holes or from the direct collapse of massive clouds of gas and dust. These black holes have masses of millions or billions of times that of the Sun and are found at the centers of most galaxies, including our own Milky Way. In the next segment, we will explore the different types of black holes and their properties. There are 3 main types of black holes: stellar black holes, intermediate mass black holes, and supermassive black holes. Stellar black holes are the most common type and are formed from the collapse of individual stars. They have masses ranging from a few to tens of times that of the Sun and are found throughout the galaxy. Intermediate mass black holes are less common and have masses between 100 and 100,000 times that of the Sun. They are thought to be formed from the merger of smaller black holes or from the collapse of massive clouds of gas and dust. These black holes are still relatively poorly understood, but they may play a role in the formation of supermassive black holes. Supermassive black holes are the largest type and have masses of millions or billions of times that of the Sun. They are found at the centers of most galaxies, including our own Milky Way. These black holes are thought to be formed from the merger of multiple intermediate mass black holes or from the direct collapse of massive clouds of gas and dust. Black holes have several properties that make them unique. One of the most important is their event horizon, the boundary around the black hole beyond which nothing can escape. The size of the event horizon depends on the mass of the black hole, with larger black holes having larger event horizons. Black holes also have a spin, which is a measure of how fast they are rotating. The spin of a black hole can affect the properties of the matter around it and can even create jets of high-energy particles that shoot out from the black hole's poles. In the next segment, we will explore the effects of black holes on the space around them. Black holes have a profound impact on the space around them. Their immense gravitational pull can distort the paths of nearby objects, causing them to orbit around a black hole or even be pulled into it. This effect is known as gravitational lensing and is used by astronomers to study distant objects in the universe. Black holes can also create accretion disks, which are disks of gas and dust that orbit around the black hole. As the material in the disk spirals towards the black hole, it heats up and emits radiation, including X-rays and gamma rays. This radiation can be detected by telescopes and can provide valuable information about the properties of the black hole and the matter around it. In addition, black holes can create jets of high-energy particles that shoot out from their poles. These jets can travel vast distances and can have a significant impact on the space around them, including heating up intergalactic gas and triggering the formation of new stars. Despite their destructive power, black holes also play an important role in the evolution of galaxies. They can regulate the growth of galaxies by heating up or expelling gas, and they can also trigger the formation of new stars by compressing gas and dust. In the final segment, we will summarize what we have learned about black holes and their place in the universe. In this video, we have explored the fascinating world of black holes, the most mysterious objects in the universe. We have learned that black holes are regions in space where the gravitational pull is so strong that nothing, not even light, can escape. They are formed when massive stars collapse under their own gravity, creating a singularity, a point of infinite density and zero volume. Black holes come in different sizes, from small ones that are only a few times more massive than the Sun, to supermassive ones that are billions of times more massive than the Sun. They have several properties that make them unique, including their event horizon and their spin. Black holes have a profound impact on the space around them, creating accretion disks, jets of high-energy particles, and even regulating the growth of galaxies. Despite their destructive power, they also play an important role in the evolution of the universe. In conclusion, black holes are some of the most fascinating and mysterious objects in the universe. They challenge our understanding of the laws of physics and continue to captivate astronomers and scientists around the world.